ultrasonic wave is a sound wave. Therefore, it is a longitudinal type of wave. And for this wave, alternate crystal, alternate compression and rarefactions are produced. We know that the audible range is, that is, we can listen only limited frequency, which lies between 20 Hz to 20 kilohertz. This is known as audible range. That is, we can hear only limited frequencies, lies between 20 Hz to 20 kilohertz. In this frequency, when we consider the frequency 20 kilohertz, this frequency comes under the ultrasonic waves. Therefore, the wave having frequency above 20 kilohertz is known as ultrasonic wave. When we consider its frequency 20 kilohertz, this frequency is very high. And when we consider its wavelength is low. Therefore, the ultrasonic wave have high frequency and low wavelength. Therefore, it has variety of application. Therefore, we study the applications, properties and detection and production of the ultrasonic wave. Okay. The wave having frequency above 20 kilohertz is known as the ultrasonic wave. Now we have to study how the ultrasonic waves are produced. There are two methods are used for the production of the ultrasonic wave. One is called as the magnetostriction method, and second is called as piezoelectric method. Magnetostriction method and piezoelectric method. In magnetostriction method, it is based on the magnetostriction effect. What is magnetostriction effect? If a rod of ferromagnetic material, suppose this is a rod of ferromagnetic material, that is iron, cobalt, nickel, as considered as ferromagnetic material. If we consider a rod of such a material is placed in a strong electric or magnetic field, the length of, there is change in length of the rod takes place. The length of the rod changes, and if the length changes, then if we vibrate this rod by means of some power supply, then the vibrations or oscillations produced is of the order of the ultrasonic wave. And second method is called as the piezoelectric method. This method is based on piezoelectric effect. What is piezoelectric effect? If we consider certain crystals, say quartz, Rochelle salt, or tourmaline, if such crystals are stretched or compressed along certain axis, then the opposite axis are set into vibration, then the vibrations is of the order of the ultrasonic wave. Therefore, for such a crystal, if we consider there are two axes, say we have to consider there are two axes as electrical axis. Suppose this is electrical axis, then there is another mechanical axis. Both axes are perpendicular to each other. Suppose we have to stretch or compress the crystal along electrical axis. Suppose we have to consider this is the electrical axis, and we have to consider suppose the crystal is stretched or compressed along the electrical axis. Then on the opposite axis, a potential difference is produced. This is known as the piezoelectric effect, and this effect is used to produce the ultrasonic wave. Therefore, the crystal is suitably cut and it is placed in a parallel plate condenser, and if this crystal is given the alternating EMF, then the crystal is set into vibration and the vibrations is of the order of ultrasonic wave. Therefore, if the natural frequency of the crystal becomes equal to the frequency of the applied EMF, then the crystal is set into vibration and the vibrations produced is of the order of ultrasonic wave. Therefore, by means of piezoelectric effect or by means of piezoelectric oscillator, we can produce the frequency nearly about 500 megahertz, and this frequency is of the order of ultrasonic wave.